Hi everybody, so I'm going to talk to you about transcription and translation. As you can see right here, well, as you may know, transcription is when you take a double-stranded DNA molecule and make mRNA, and then translation will take over after the mRNA to make amino acids so you can make proteins. So I'm going to take you through how transcription starts first. In transcription, as you can see, sorry, I'm moving the paper, you have your double-stranded DNA. What will happen is an RNA polymer, it's a certain enzyme, will find a certain region called a promoter, which is a sequence in your DNA, bind to the promoter, and then move along and start coding with these certain nucleotides, other nucleotides that are complementary. So as you can see in DNA, if right here the DNA strand has a T, the complementary nucleotide for that is the A. But in mRNA, there is no T, so if there's an A in a DNA sequence, then it'll code for a U. And then, as you can see here, G and C are complementary to each other. So, and then your RNA polymer will move down, and then it'll stop transcription at a certain spot called a terminator. And once you're done with that, your mRNA sequence is made. Found a picture online to show you how it looks like if it could give you a little bit more in-depth, like an in-depth a more in-depth like view on it. So now you have your transcription. Now you have your transcription product, your mRNA. Once that is done, translation is done. Translation starts taking place, where every 3 nucleotides codes for a certain amino acid. So as you can see, AUG codes for methionine. You can see it on a chart, which will usually be given to you, a codon table about all the amino acids that come from each 3 nucleotides in a certain pattern. So as you can see, this is done by ribosomes. Ribosomes will start at, this is your start codon, and go all the way down. And then at a certain point, there's a stop codon, which is UAA. Once this is done, you have your amino acids for your proteins. And here's a picture of how it looks. As you can see here, it's coding for certain amino acids. And that's about it.